Hi everyone, and welcome to my channel. My name is James, and I'm an independent game developer, and I'm also a senior technical artist at Unity Technologies. So in my spare time, I like to do prototypes and R&D and kind of work on these hobby projects. And one of them has been this skateboarding character who can ride on this ramp. And I had a lot of folks comment and give positive feedback on a video I made last year that showed a character moving along a ramp really smoothly and natural looking. And a lot of people had asked me, how was that done? So I thought I'd take this moment to make a video here to just informally walk through what I did. And this is my R&D prototype. So as you can see here, we have some errors and it's broken that we're going to fix. And it's not complete, but I'm going to go into the code that I wrote for this and show you all of the Unity components that I did to build this up. I did this prototype in 2D because it was much simpler, but it was due to the nature of Unity's 2D being sort of utilizing the 3D aspect of the engine. This is very easy, just use the 2D over top of 3D elements. And so to everyone who watched my videos, it looked as if this was a full 3D environment and there were some more complicated 3D physics going on, but there were not. So if we look at this prototype here, we can see this is flat 2D sprites. There are no depth in the Z for anything. And so that's how I worked with it initially. So I wanted to make some really unique collision that just was not very easy to work with, or some of it wasn't even possible to create by default in the Unity editor, these custom type of 2D colliders, and the way that I wanted to work with them and shape them in the editor with handles and stuff. So what I did was I grabbed a custom 2D colliders library that was open source on GitHub. Here it is by a Mr. Guy Quad. But you can go in here and just find custom 2D colliders. And there's several different types of colliders here that you can import in off of this Unity package. The package is quite a bit older. It works fine as far as I know, and anything in the 2018-2019 series up until 2019-4, I believe, in which one of these libraries for handles in the editor changed a naming convention, and so we'll fix that. Here is a quick little video run through here by Mr. Guy Quad on how this works. So as you see, this is a curved collider 2D, and you can use these handles to kind of shape this collision in any way that you like. And that was the sort of convenience that I needed because the ramp had a lot of curvature, concavity, and things like that that I wanted to work with. But this just became a really cool library to work with in general. And again, I was working with it in 2019.1 or 2, and there were no issues and no errors. But in 2020, there did pop up an error about handles, which I left in, and we're going to solve that. This ellipse collider was really handy. Kind of nice to be able to make stuff that isn't just a perfect circle. So there are quite a few cool colliders in here. The Capsule Collider 2D is pretty awesome. I believe in one of the very latest versions of Unity, they do have this collider. I'm not entirely sure. I don't do a tremendous amount of work in the 2D aspect of the editor. So let's go back to Unity here and just solve this. So I imported this package into 2020.27F1, latest stable release of 2020. And we get this handles does not contain a definition for cone cap. I'm going to double left click this and it will open it up in Visual Studio, and we'll see that the error is underlined here. It has to do with cone cap. So when I went to Google and looked up the cone cap terminology here, it returned something called cone handle cap. And that was telling to me that the name of this specific part of the library for these handles had probably changed. So what I did was I went into Visual Studio and I did an edit, and then we did find and replace, a quick replace, and I looked for cone cap and then pasted in cone cap handle, and we went to the next, and I'm just going through one at a time just to make sure we're not replacing anything else that we're not supposed to. And so far, we've resolved all of the errors. So I'm going to hit Control S and save and return back to the Unity editor. And after a hopefully quick recompile. We'll come back in here and all of our errors are gone. And what I'm going to do is just hit play. And we will check this out. Okay, so I'm going to hit left and right on the keyboard. It's a little slow by default. And we'll see that the character is smoothly riding up and down the ramp. Let's close the console. And the character can develop a realistic looking momentum and always hits the ramp in the right spot, doesn't come down and kind of wreck into that metal pipe or what the skating industry calls the coping. And we can go up quite high. And then when I let off the keyboard, the momentum and gravity take hold and the character realistically slows down and comes back down. Now I can hit up and down on the keyboard and we can ride up and down to the upper extents of the ramp. I will get my character's momentum and velocity going back up again. And then in air, I will hit the keys and we will have the character kind of fly up and down to the further extents of the ramp and then closer. And then as I press up, the character is constrained and will not fly off the top of the ramp. And as I press down, the character will not exceed these extents. So if we look in here, let's pull these two windows apart so that you can see more closely what's really going on. And this is going to be interesting. As you can see, these are the spline handles from that custom collision library that you saw. If I pull one of them, which I'm not going to do, we'll change the shape of that collision. So we'll see that the character is really riding smoothly on that collision. What gets really interesting is when I move the character up and down. So you see the collision is moving up. Ignore the fact that the handles don't move with it. It's not a big deal. The collision is moving as it should. Now, since this is a prototype, as you can see, the collision itself is not properly rotating with the artwork. They are separated, which is something I tend to do all of the time, which is separate the art and the collision. And so as I press up, the collision is moving up the ramp. And it not only moved up, but since this is 2D and we don't have any true 3D depth, it's actually scaling down the collision object. I believe we could see that on the transform. So if we look over here, you see the transform scales 0.65. As I come closer to the camera, 0.78. As I come very close to the camera, it goes to the maximum size that it can be, which is 0.97. We can allow it to become all the way to 1, and it would grow and probably increase the extents that the character could travel up and down this ramp. So as we go up, we're scaling the collision down. And it gives the appearance or illusion that the character is actually moving in 3D up and down this ramp, which is interesting. So it's just an illusion, a neat trick. As for my player, the player has a rigid body 2D on it with a physics material player, which is a very low friction material, just so it slides very well. This is the root object of the player. The player has a left circle collider, a right circle collider. They're just supposed to behave eventually when the prototype moved along further. They would behave as wheels in a sense as the character sort of rotated up this collision spline here instead of staying up. This is a raycast, which is shot down from the bottom of the player, down in the y-axis, into this collider here. And this raycast that goes down is taking sort of the difference in the angle here, the normal, and an average of that coming off of this towards the player, and it is allowing the player the artwork to rotate and give the appearance that the character is rotating. This is just a target for the follow camera. And when you saw the artwork rotating, that is this aspect right here. I named it rotate. Everything inside of that will rotate based on the normal or curvature of this curved collision here. And you can put all of your artwork in here. So I put the base character in here. I figured that this would be sort of a 2D character or a humanoid character where the legs would be down here and the shoulders and upper torso would be here. And so that the upper part of the body could rotate independently and the arms could swing and all of that sort of stuff. I didn't take it a whole lot further than just establishing a pivot point for that to work. And that's about as far as I took that. And if we go and you'll see as I push the character towards that part, the character leans into it. You'll see the top part of the character. That would be the shoulders and arms and head and everything on a sprite leaning in that direction. And then you'll also see the artwork rotating to match the curvature of that collision. So very simple, a couple of circle colliders, the rigid body 2D, this rotation element, and then a rigid body 2D collider on here. I froze the rotation around Z, and that is exactly why it is not allowing the collision to turn or rotate around Z here, this blue axis. Just in the R&D phase, I lock that out. So let's take a look at this script. So we have a rotation speed, which is the speed that the character can smoothly rotate along this curvature. Power is basically sort of like an engine thrust, or since this is a human character on a skateboard, basically the power or strength of your input from the keyboard or controller. This rotated transform is this rotate right here. It's the entire character's rotation. The raycast transform is where we shoot the raycast down, which is this object. It's shooting that raycast down into the collision. Is grounded, just checks if this raycast can still detect this collision. And that was on there because before I got to this phase in the R&D, there was a point that the character was flying off and coming off of this collision airborne. And I thought, well, we will check to see if it's grounded for future reasons, for tricks where you sort of leave and spin maybe and leave this collision. We just want to know if we're grounded. And also I was going to potentially use it to see if we could use it as to split this collision in half so that there's air collision and then technically ground or surface collision. So we know that when this character or player is touching the ramp versus when this character is flying in the sky, and that would be really handy as well. What I just mentioned about the player flying off of the ramp was solved with applying this downforce, negative 300 units of downforce, which is just a force, add force down on the rigid body to force it down. And then reverse tilt was just sort of R&D functionality that I built in to control the upper tilt of the upper body of the character. So I could sort of, I liked it reversed, but we could keep it forward where the character leans into going up the ramp rather than leaning back. I just wanted that option. Tilt, yep, that is the rotated tilt that we do, the reverse tilt on the upper body or shoulders. And this is the angle of how far it tilts. So we could increase the amount, like if I put it at 30, we can increase the amount that the player, you see now that the player really leans. So we can make it subtle. We could make it really subtle. And like now it's really subtle. Whoa, I zoomed in. I hit a hotkey. We might want to detect the direction of the motion as well, because right now the player could be going up and leaning in an unnatural direction because the tilt is based on the input on the controller. So it can look a bit unnatural. Vertical speed, we're going to have to look in the code. You'll know I'm a technical artist for the most part, so I'm not a software engineer by trade. A lot of my code that I write is prototype code or sort of R&D. And so we revisit that code after we make a prototype, and we have to sometimes, if we don't code comment well, make sense of why we put this field in here, or this variable. Like, what were we trying to accomplish with this? Vertical speed, I'm not sure if that was something to slow the character down as they moved up. Oh, okay. Nope, I do remember. So vertical speed is the speed. This is why it's really important to have descriptive field names in here. It is the speed that this travels up and down. So if I double it to 2, we see that we can move up and down much faster. But then we get a problem of the character sort of hopping as it bounces off that collision. The collision is moving faster than gravity is holding the character down to it. We could let's try something more extreme. 5. Yeah, look at that. So that vertical speed is the up and down speed of that collision moving, the fake. 1 felt good. What it really needs to be tied into is the motion either left or right of the character. Because right now I can move this character on the skateboard up and down the ramp without any forward motion of the character, which sort of makes no sense. So if the character is moving forward, we allow this to move up and down, right? So we would do some kind of multiplication based on the character's velocity in either negative x or positive x, and sort of do a bit of math to tie that into the vertical speed. And we only allow this, I could probably multiply it times that. A naive first approach would be just to sort of multiply a division of that velocity. To only allow this up and down movement like this when the character is actually moving. As we can see now, we can move up and down with the character sitting still, and that's not right. Scale speed is how fast it scales. So how fast it becomes large to small. If we set this to 1, you'll see how we get inaccuracies. So see, scale speed is not matching. It takes a while now to do its scale thing. That was sort of this, that 0.39 was sort of the sweet spot where it scaled and matched the ramp beautifully. And we just allow that to tweak it based on sort of vertical speed. Yeah, see that now the math on this is really bad. Those just need to work in tandem for sure. And then collision is reference to that actual collision that we're moving up and down and that we're scaling. And then I do believe velocity. Velocity was where I was going to check the player's current velocity in X and Y, and I don't know if I had actually got there yet. So as we look through here in our script, we see the typical fields in here. I try to keep these private ones all up here, privatized, because we're not going to mess with those in the inspector. Access to the rigid body 2D, access to the transform component of what this script is on, which is the player. These are the inputs, horizontal and vertical. We put those up here as a field so that I can kind of alter what represents those later on down in the code. So those could be coming from a gamepad. Those could be coming from an arrow on a mobile phone screen or a keyboard key. Tilt around Z is a private variable that we're going to feed information to for this tilting around this. Okay, it's a private field that we have for that. Y move, I did not comment for that, so I believe that is something to do with the up and down velocity. We'll have to look at that. And then these are unused, clearly. So I think these were needed at some point, and then they're unneeded now. Rotation speed we showed. That's how fast the player rotates this quickly around Z. Power is, we saw that in the inspector. That is how powerful the thrust is of the player up and down the ramp based on user input. The rotated transform is this root transform that rotates the art. The raycast transform, at least I started commenting here. It is a channel transform used to cast our ray down, and that is so that we can basically get feedback from the raycast hit on this collision here and feed it back to the player, and we can kind of average that to set the rotation of this player. We can actually take the hit data that comes back based on the angle and allow it to rotate that. Is grounded? Are we down touching this collision? Down force is where we used the add force on the rigid body to push it down onto the collision and hold it down so it doesn't fly off into outer space. That was happening. Reverse tilt was just so that I had some control to invert the rotation of the upper part of the player's torso if I wanted. Player root is the root transform that we would be rotating or tilting. And then this is that tilt angle, which you guys saw that we could increase or decrease. There is some cool stuff I was working on that was working, but I had to backtrack on it as I took a new approach, and it was to compress legs, knees, artificially. So without the need to, or procedurally is the better word, without the need to create any animations. And that was the goal with the tilting the upper part of the torso, compressing the knees. It was to build in all these functions that would make this character pretty much procedural. And all you'd have to do is feed these sprite body parts to it, and you wouldn't need to animate anything. Vertical speed, not sure how I'm using it just yet. Oh, yeah, that was the speed up and down the ramp that we move this curved collision based on the WS or up and down keyboard arrows. Vertical speed was how fast we moved that vertically. Clearly, I need code commenting. Scale speed was how fast or slow that this collision here would scale down as it moved up the ramp. So we could tweak that. And then minimum position and max position were setting in the Y coordinates the minimum down position that it could go, and then it would stop. You couldn't, based on keyboard input, you couldn't push it down any further. And max position Y was you can't push it any higher than this amount. And then this access to the transform of the collision, this is where we're actually moving the collision and scaling it based on its transform component. And then the velocity of the player, which even though we're not using it now, it looks like it's being referenced somewhere. So we have a start method here. And we say if the collision is present, if it's been plugged into that slot in the Unity Inspector, if it's there, set a starting scale and just say that that is its local scale that it already has, right? Local scale. So if it was a child of something else, it would be the scale locally of it. Else, if the collision's not there, then spit out some kind of error in our console that says, hey, you need to assign collision to the player. Here we just caching a few components, which is really common to do in this start method that just runs at the scene start. So this way we're not trying to repeatedly grab a component this many times, 60 times a frame or 30 times a frame. So we get it once, and we can use it all through the code. So the TR is just getting the transform. The RB is just getting that rigid body 2D. Always cache your components in awake or start. And then in update, we have all of these different other methods or functions that we run. The first one that we're doing is, looks like we're checking velocity. And as we can see, the R&D state of this check velocity is empty. We're not doing anything with this, so we could literally just comment that out. We're not checking the velocity, but I think I explained a little bit earlier on why we might want to check the velocity. Then the very first thing we want to do here in update is check the input. And this is where we kind of use those horizontal and vertical, and we modify other elements based on these float values for horizontal and vertical. But they could equal all kinds of cool things. So right now they equal the axis horizontal in the input settings, but they could equal a button down from a UI button. And so on mobile it would be when you press a button, or it could be input get touches or something like that. So check inputs would be very versatile depending on the platform. The next thing we want to do after we've checked who's pressing what on the keyboard is we want to align that ramp player. So we want to make sure that root object is aligned to that curved collision. And so align player, let's go down here. I hate empty white space. This is where we do that raycast. So we do a 2D raycast. We're looking for a hit. Where this raycast is shooting down, what is it? Let's store this variable for what it's hit. This collision right here is the only thing that it's going to hit. So we take that raycast transform that we made here at the very bottom underneath the player. We take its position. We invert vector 2 up, which is vector 2 up is the y, up. By making it negative, we invert it. So we say check down, right? And then we do that raycast out 3 units here. And then we have another variable that says the ground distance. So is the hit distance. So the distance between this raycast and the object that we hit here. And I don't think we're using it just yet. We're not. This was going to be part of that detecting. Are we off of the collision? I'm going to have to look here. Again, we have to sort of, I have to sort of make sense of what my logic was at the time that I wrote this. If I have the other grounded property I did, I might be checking if I'm grounded against the collision a different way. Maybe this was because I wanted to know how far I was away from the collision, and that was important for one reason or another. So the ground tilt, this is just where we're doing that tilt rotation, where we're rotating the entire character, and we're going to also do a rotation of the character's upper torso, I believe, in this all this align ramp player stuff. Ideally, I would have broke this out and I think separated this into a different method or function that was just for tilting the upper body torso of the character. That way I don't get too confused, because I think just aligning the ramp player to the ramp doesn't really speak to me about rotating elements of the character's body, like arms and stuff like that. I think that's what's going on here, but we'll dive deeper. So that's the align ramp player, and compress knees was coming, but didn't get finished with it. So control tilt. Maybe I did break these out. So control tilt. Look at that. I did. Okay, so align ramp player was only handling aligning the entire player to the ramp. So this control tilt is working on the upper body here. So we're just saying this is the option for the reverse tilt. So for doing reverse tilt, take the horizontal input, which is those A and D keys or left and right arrows, moving the character back and forth, and take that tilt around Z, where we're rotating around Z like this, and then invert it if it's reversed. If reversed tilt, just a Boolean, true or false. If it's true, invert it. So we want to reverse the tilt. If reverse tilt's not checked in the Unity Inspector, it isn't, the little checkbox isn't ticked, then it's false. And then we'll say, just use the default tilt angle. And then we set a temporary variable, a quaternion rotation here, which is really just the target that we want to rotate. And we say, hey, take the player root, set its local rotation to that target with a quaternion slurp. Quaternion slurp is a nice, smooth, sort of over time, like a lerped rotation. Quaternions and things like that and Euler angles are a little complicated to sort of wrap your head around. But what this does is a nice smooth rotation versus just doing transform rotation, which is sudden and has no easing to it. So there we go. Let's go back up. So we have move spline. Clearly this was to move the collision spline right here. This is a method or function that just moves it up and down. That's all it controls. Let me kind of collapse some of these methods here so we can get a better look. So we're looking for move spline. We looked at control tilt. We looked at align player. Move spline. So moving the spline, that's what the Y move was for, and I couldn't make sense of it earlier, and I'm trying to reverse engineer in my mind what that meant. And this is why it's so important to code comment and then name your fields or your variables something that's very apt or appropriate. So I would have said Y collision move, Y collider move might have been more helpful, because Y move doesn't tell me if this is collision, the player, Doesn't tell me anything. So it's to move the spline. So we take the vertical input, which is the W and S keys, or up and down arrows, and we multiply it times that vertical speed divided by 2, and then times delta times. So let me wrap my head around what we were doing here. Okay, so this is where I was going to start doing a little bit of that math, where I would take the speed. We don't want the vertical speed, we want the horizontal speed. I believe that's what I was trying to do there. And we would move it based on if the player was moving. And so we wouldn't allow the movement of the spline if there wasn't some horizontal movement of the player. But I'll wrap back around. The function is working, but I have to figure out what I was trying to do there. That's interesting. So here in move spline, I just say if that spline transform, the collision, again, a horrible variable name here to let me know that this is really a transform and not collision. We just translate it in the 0 and X and 0 and Z and according to Y move in Y, up and down. And then we just clamp it. We set a vector 3 for all 3 of those positions that you could translate from, all those vectors. There's 3 of them. There's like Y, X, and Z, and we just want to clamp it. And so we say that the Y of that is going to be clamped, the up and down, based on that min position Y and max position Y, which is the maximum that you could go in Y and the minimum you could go in Y. And then we say, all right, set the position to that clamp position. So that's pretty straightforward. Clamping movement, taking the input right here to move it with vertical, that is the up and down and WS keys. So move spline is pretty straightforward. What do we have last here? Scale spline. Okay, last one. And I saw it down here. Scale spline. So we just check if the collision is present. And honestly, we don't have to keep doing this. I do this a lot in prototype code. But if this is checked in start or awake, if the collision exists, if that component or field has been assigned to, then I don't need to keep checking in every single method. But as I prototype in R&D, I don't know yet if other bits of code I'm going to write, other methods or function, is going to disable or delete or game object destroy this collision for one reason or another. Now I can't possibly postulate on why I would do that, but let's just say I did write another method that did. And so I check here and say, well, if it's still there for one reason or another, but that is not a good practice for production code. So if we have that transform for the collision, we want to scale it. Let's set a new scale. We're going to say that that new scale is its current local scale that it is at that moment. New scale is going to be, we're going to take away from or deduce the local scale times Y move. So that is our up and down movement times the scale speed. So that's why when I press the keys and we move up and down, it actually does change that local scale based on the Y move. And then we also clamp that scale so it doesn't exceed, trying to find the ref, the new scale, okay. And so we clamp that to new scale. I'm trying to wrap my head around what that check is for. It is just a clamp to ensure it doesn't exceed the bounds of new scale. New scale is created inside of this method. I guess it depends on how much scale spline is being called. Oh, well, it's a clamp and it works. It is being clamped. It doesn't continually keep scaling. We'll have to see what we do with new scale. Well, we don't do anything outside of it. It's created inside of this method. Yeah, I'll have to spend some more time looking at that. Just know that the clamps this and doesn't allow it to exceed that new scale. Oh, hold on. Okay. That's why we don't have a math F clamp in front of that. I had a bit of a brain fog there. We set the local scale to a method here where we send into this method the new scale, or basically new scale is that current local scale that we keep changing. We make it less as we go up. We make the scale higher as we go down. we say set it to equal to this method that we're going to run this method, and we're going to send this method that scale. And this is the clamping function. Okay, helper function for clamping scale. So here it is. We just take the x, y, and z on that, and we clamp all of those values. That won't go any less than this, and it won't go any more than this. And I have, during my R&D and prototype phase, I have hard-coded these values in, but clearly we don't want to do that. We would probably clamp them in the same way that we did up here, minimum position, max position. And we would set to for min scale, max scale, and then put them in here. I put hard values in for the time that I was just rapidly iterating. I had established this, I think, in an afternoon. And so that's why. So there you go. That's, I don't know why I had the brain fog there. When you're going to use a clamp function that Unity puts forth, like a mathf.clamp, that is a built-in Unity method there for that. And so I decided to use my own my own method here for doing the clamping. And that's why it confused me, because I used a similar wording for that method that Unity uses. So just for reference to look at this code, if you want to try to use some for yourself, there's the clamp method, there's the scale spline, there is the moving spline for moving the collision spline. Here is on collision enter 2D, on collision exit. This is for the grounded. It's pretty clear to me now because I didn't set a tag of ramp on this collision, which is what I would have done. Let me double check just to make sure I didn't. Yeah, there is no tag, so I would have tagged it ramp. That's interesting. So these are just unused functions at the time to determine if I'm still touching this collision. That could be really handy, especially when you're going in the air and doing tricks and stuff like that. That makes complete sense, but they're unused for the time being. This is the align ramp player method. I commented out a debug draw ray, so you could see that raycast coming down and touching the collision if you want, just to kind of debug that. So the align ramp, control tilt. It's a control tilt function for backtracking back. I think just tilting the upper body of the character. You would definitely want to extend this and set up your artwork in a way that allows you to tilt or rotate whatever parts you want, whether that's arms, chest. Fixed update. I don't think we actually covered that. Okay. So in fixed update, we should have probably broke this out into its own function for sort of clamping where the player could go. So we're checking the transform position Y. So this is this transform of the object that this script is on. So this player, when it's going up and down in Y, we say that if it's greater than 1.3 units up, this scene's not very big at all, then return, go back. Don't go any further down in fixed update. And the reason that we have an exit here, so if we're higher than 1.3 up in the air, don't add any more force, because this right here is all of the gravity and the force. And we say don't do that if we're up high enough. The reason being is you could keep adding force to the player higher and higher and higher and send them off the planet. So we just say if the player's gone this high, don't add any more force. Now you could tweak this value and say, I want my player to go extremely high, or I don't want my character to go as high. So it just returns, which is telling this method, don't go past this bracket, go back up. It puts it in a loop right here constantly. Boom, 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 checking. But if we're not greater than that, keep allowing this force to be applied. And we add a relative force, which is relative local to this rigid body. And we say take the power, which is sort of that thrusting ability, times the horizontal, the A and D keys, the left and right arrows. We don't apply anything in Y. And then take that power and apply it for vertical too, the W and S, the up and down. And then just add that force, right? And then we also do the gravity, which is that down force that holds the player. It is a relative force, which means it'll hold it down, not in the world, but relative to its rotation and position here along this collision. It'll sort of force it down into the collision. This is the fake gravity, or a down force like you would have on a car, where a car spoiler pushes a race car down. So we could probably break these out of fixed update. They are physics forces, so they do belong out of fixed update, but you could call the method in fixed update and break this method out, because we might do quite a few different things with the physics after this. But right here, we're just adding the force to push the player, move the player up and down, and then to hold it down to the collision. Check inputs was really simple. Just checking the keyboard and the inputs. Check velocity is empty and unused. And these two are also unused. These were going to be getters and setters for, looks like they might have been lerping a transform, frame velocity in previous position. Definitely might have been something for sort of lerping position. I don't think it's rotation, but they're unused. Don't sweat it. And then these are all of the methods that we're calling out of update. We want these to all be checked and called every frame of our game, so they're called out of update. Don't worry about the ones commented out. And then in start, we cache these components, we grab reference to them, and we just make sure that we have this collision transform and that we set its scale. And then these are, let's see if we can fit all of these. We can fit all of these variables or fields in here, and some of them are unused. If they're gray like this, they're unused in the code, so we don't need them. And hopefully that is a decent start to getting this kind of system set up and working for yourselves. Now, you don't have to use this custom 2D collider library that I used. I believe you can use a polygon collider or an edge collider here, a built-in Unity one, and then you just have to go in and manually, but you have to manually move those vertices and try to make it nice and smooth, whereas this individual's library allowed me to make collision out of a Bezier curve, which gives me a super nice smoothness. So I would highly recommend going back and looking at this. And then when you see the red errors, if you are in Unity 2020 or something more recent, make sure to swap out and change this the name of this method here for handles that causes those errors. They go away and everything works beautifully in 2020 when you do that. And it's really cool. And this translates perfectly fine into 3D. I would say the next steps on this would be getting the collision to rotate alongside the art and solving any issues that would result or stem from that. Visually, it looks really cool. So it looks like I'm literally flying up and down the ramp, but it's really all just a big fake in 2D. So I hope that this gives some insight. I would say one of the future things I might want to do is the player might want to ride up on this flat platform up here. So we would have to break our collision probably right about here and split it, and then have another piece of collision up here separated from this collision. And we would disable this collision here and enable a nice collision here on the platform to allow the player to skip up off of this and then get vertical up on this platform here. And we'd really have to wrap our heads around how we would pull off that transition. But that's an interesting problem to solve. Thank you for taking the time to watch this, and hopefully it gives some insight into how this was done. If you have any questions, feel free to hit the comment section down there. Thank you.